everyone, my name is Kai Maeda and I'm a graduate student in the Chemical Engineering Department. And I want to talk to you about our startup company, Sage Energy Solutions. I'm going to start by thinking about the problem if you consider NATO forces. In particular, there are 28 member countries, and of course the US military is one of the largest contributors. Now let's look at a NATO soldier. So tonight we'll call him Taki. So Taki knows for any military operation he needs to go into, he needs his equipment, his food, and his energy for his devices. And it's this energy part that really bugs us. Especially when you consider that for a 3-day mission, he needs to carry 50 pounds of batteries. 50 pounds. That's a lot of weight for 3 days. And what this 50 pounds does is it reduces his mobility, it reduces his ability to carry out other pieces of equipment which may make him safer or more effective, and it obviously just reduces how much things he can do in the field. So this 50 pounds of batteries can be shaved down to 5 pounds with something called a fuel cell. Problem solved. Done. We don't need to do anything else. Well, not really. The real problem is that the fuel cells that the military are interested in uses propane. This is the same propane that you use in your gas grills, widely available, cheap to buy, easy to store and transport. Let's just ship it in. We are the US military. But the real problem is that propane is not available in the battlefield. And the reason is because if you take a look at a map of Afghanistan, attacks on the US military are primarily centered around convoy routes. So just ship it in is not nearly as easy as said as done. I'm sorry, not nearly done as said. And what they only have access to is NATO jet fuel. And they ship this in with all of the devices. So obviously they use it for their jets, but less obviously they use it for their Humvees, their tanks, their M1s and whatnot. So the question now becomes, can we use jet fuel to somehow enable these energy-dense devices called fuel cells? Well, in comes Sage Energy Solutions to the rescue. We've got a nanomaterial that our CTO here has designed and synthesized. He calls it platinum gadolinium ZSM5. For the rest of us mere mortals, we call it fairy dust. And the fairy dust is what we're building our entire company off of. What we can do is we can catalyze a reaction that goes from jet fuel to the propane. This is the exact same propane that I was talking about before. So now Kaki's a much happier soldier. He's nimbler, he's lighter, he's more agile. Furthermore, propane in the battlefield now means you can use it for heating and cooking as well. And this, finally, you can also contribute to your silent power production from your vehicles. So it's very versatile. Our core team is composed of 4 chemical engineers, and our scientific credibility is anchored by this good-looking guy on the left, Dr. Joachim Lauterbach, who commands over 20 years of R&D, as well as $10 million in research funding. In fact, this project started with a $1.2 million grant from DARPA, and we've recently won the Fuel Cell Challenge, which we used to develop our LLC and then actually produce our first prototype. Now, I understand that 4 chemical engineers isn't the best course to bet on when it comes to a startup company. So to that end, we're bringing on an advisory board who we're using to help us with our legal advising, our IP strategy, as well as our business planning. I'm not allowed to disclose who the 4th person is that we're bringing on because we haven't finished our negotiations quite yet. But needless to say, he has 20 years of startup experience and over $40 million of capital raised for his technology development companies as well. Our go-to-market strategy starts with the technology. We have a host of unfair advantages. First of all, our chemistry is very simple, right? We only require fuel and air. Our competitors require water, which can sometimes be more valuable than fuel itself in the field. They also require oxygen, nitrogen, and hydrogen, which are obviously unavailable if you're a military soldier. Our catalyst is durable, it can endure multiple cycles of reactions, and it's very efficient. In fact, the military's minimum requirements is 5% conversion. That's how painful this is for them. We do it at 50%, 10 times. Finally, our catalyst is flexible. So tonight I'm talking to you about jet fuel, but it turns out it works for diesel, gasoline, and kerosene too. So all of these fuels can be reformed down to propane. With our technology, we're currently in the process of negotiating exclusive license from the university. We'll take this exclusive license and turn around to our strategic partner who we can team up with. We're currently speaking with 4 entities on this front. All 4 of them have developed fuel cells. All 4 of them have sold products into the military market, and all 4 of them have the know-how to develop and commercialize our particular technology. Once we've identified a strategic partner that we want to work with, our revenue generation comes in the form of sub-licensing fees, consulting fees, as well as royalties on sales. And we plan to start selling items in the latter half of 2014. Our revenue generation would then be reinvested into our company, and we'd be looking at expanding our markets outside of the military realm. So I want to bring it back to Kaki. If you remember, he was carrying 50 pounds into the battlefield. And with our technology, he's going to be much lighter, much happier, and much more effective as a soldier. But we can think about other people who are operating in the same space, right? So the Philippines, think about disaster relief crews. Or maybe, refugee camps in Syria. Or what about the tornado-stricken area in the Midwest? All of these crews come in with gasoline and diesel, and they typically don't have access to fuels.